The 3D printing community wanted just a bigger Bambu Lab printer, so they listened, and this is their new release, the H2S. At first glance you might think this is just the H2D with a single nozzle, but don't get fooled, as you'll see even small changes can affect its performance. So let's talk about them. First, let's address the elephant in the room. Both of these printers appear nearly identical, so how they can perform differently? In fact, there are so few changes that we can count them on our fingers. We have a different toolhead that reminds us of a 1 series printers, we have a filament cutter that is only on one side instead of two, we have a slightly different waste management system, but the accessories from H2D still fit, and even the outside of a printer is basically the same, with some plugs for non-existent second hot end and no windows to peep inside the printer, or in my case to stare at an ugly wall. So, did I lie? Well, no. You see, just by changing such a bulky printhead, we'll have improvements in some areas and downgrades in another. A way lighter toolhead means less mass, which leads to fewer artifacts at high accelerations and speeds. By putting the theory into practice and running the test with gradual increasing acceleration, we can see that both H2D and H2S perform very well. They even have fewer artifacts than the X1C. That is impressive considering that the H2 series offers more than twice the print volume. But the heavier toolhead of H2D is no match for the lighter one, and with H2S we basically get a flawless print results up to 20k acceleration values. Just be aware that high accelerations also round corners and print details more, so rather than increasing the outer wall acceleration, increase the inner wall accel, as that won't have a significant downside for the details. Talking about the downsides, the smaller toolhead of H2S also means different filament extruding components and a smaller part cooling fan. The H2D features a single large filament drive gear for both hot ends, and it produces extremely consistent extrusion with impressive layer stacking. But the H2S comes with a smaller dual drive gear extruder. From my experience with these type of extruders, they always led to worse extrusion consistency and less clean looking prints compared to a single drive gear. At first I thought this would be the case, as the test print on H2S looked horrible, but it turned out when I fiddled with a sock in front of a camera, I accidentally loosened the hot end clamping clip. I reprinted the file with a properly fixed hot end, and I don't know how Bambu Lab did this, as the print quality was on par even with H2D's extruder and was a significant step up from the X1 and P1 series printers. All this leads to extremely smooth surfaces of the prints, even when looking at them with the worst lighting conditions that expose those irregular layers the most. However, not everything is sunshine and roses, as the H2S part cooling performance falls short compared to the H2D. But how is that even possible when H2S has way more direct part cooling? Well, I went nuts on this by printing so many test samples, and all of them told the same story. All the prints were then enclosed because automation is a big part of H2 series printers. You no longer need to keep the doors open when printing something like PLA or PTG, as we have a fancy intake and exhaust that automatically open up when printing those filaments. Looking at all the prints, the H2S part cooling just isn't that great. As you can see, the aux fan, also known as the side fan, still improves the H2S prints even when printing with the door closed, but H2D can achieve better results with both nozzles even without the auxiliary fan. I thought this made no sense, but after I checked the part cooling fan of H2S, it all made sense. First of all, it is a smaller fan, second, it is extremely restricted compared to the fully open design of H2D. And finally, the fan of H2D is way more in line with the stream of cold air that the top opening brings in. I wouldn't call the H2S part cooling performance bad, as my test prints are pretty demanding, and on larger models the difference is much less noticeable. Still, on some PLA prints I do wish it had a bit more cooling. Just as effective cooling is key to 3D printing, PCBWay, the sponsor of this channel, makes these deeper analysis possible. They offer professional 3D printing, PCB manufacturing, CNC machining, and other services for all your advanced project needs. Easy ordering of 3D printed parts from nylons to various metals, even like titanium. So make sure to check them out with a link in the video description. With all that said, that is pretty much when it comes to the main print quality differences between the H2D and H2S. If we look at more complex prints, the H2D excels in way more efficient multicolor and multi-material printing because of two hot ends. This allows us to get way better bottom surfaces using the support interface layers that would be a complete nightmare to remove otherwise. Plus, two-color prints don't require constant filament purging, so efficiency is high. But what I think the H2D excels at the most is the multi-material printing. By either combining two material types to print much more functional parts, or use material that doesn't bond well to the primary one to print parts that are just on another quality level, like this PPS-CF part. I know that a lot of you with P1 and X1 series printers want to know if the H2 series are a substantial upgrade. They have a significant price increase, so they better be, right? To answer it shortly, it basically is an improvement in all aspects. The only exception is the H2S part cooling performance. I already showed some tests where you could see those improvements, so here are more. By printing and measuring multiple single-layer squares across the whole bed, I can confirm that despite the H2 series being much bigger machines, they still offer exceptional first layer consistency. This aspect is extremely overlooked as the first layers are the foundation of our print success rate. We finally have hardens with way longer melt zones that lead to way better filament melting. From my layer adhesion testing data, those perform so much better than the stock hardens of the previous generation. The H2 series standard flow hardens perform so well that with the high flow variant we only see a small difference even at 300mm per second printing speed using a 0.4mm nozzle, so if you are going for the high flow hardens, 0.6mm would probably be the way. With all this speed comes higher noise levels, and I'm so glad that H2 series printers feel so much quieter as we can finally print PLA and PTG with the front door closed, muffling a lot of that noise. The loudest parts of these printers are the Y-axis linear rods, but that is expected as the maximum travel speed has grown twice from the previous generation to a whopping 1000mm per second. Also, sealing of a chamber and filtration is a great improvement as there is much less smell when printing something like SA. On my X1C I had to do chamber sealing modifications and add an additional filtration system to reach this kind of level. Oh, and with previous generation you couldn't even see anything inside, and now you can thanks to 2 more powerful LED bars, plus a door that finally fully opens. But what I think is the biggest improvement when it comes to the print quality is that there are practically no vertical fine artifacts like the X1 and P1 series had. I was blown away so much by that I made print after print with the shiniest PTG I had, and all the prints looked flawless. I always avoided shiny filaments on my prints as they expose all the defects, but now all I wanted to do is print shiny stuff. With a lot of printing also comes a concern about the repairability of a machine. The previous generation was quite poor in this aspect, with most parts being difficult to replace and some not even replaceable. H2 series greatly improves that as now all the idler pulleys and linear motion parts are replaceable. Everything is bolted in place to be serviceable, which is amazing to see. But no printer is perfect, and the most frustrating thing about the H2 series is how restricted they feel. You can't use the aux fan in the heating mode to heat soak the printer faster by blowing the air onto the 1.5 kW heat bed. After the latest firmware update on H2D, the vision encoder plate no longer shows any calibration precision data and only gives an exaggerated, not to scale view that doesn't tell you anything valuable. You would think that the new AMS HT units were made for engineering filaments, but they have the same limited usable range of filaments as the regular MS units. You can get past this limitation, and I was successfully loading even Bambu Lab PPS filament, but that is not something I can recommend doing, as you never know if the way high needed filament loading force won't lead to a premature failure of the MS HT motors. The new generation AMS units comes with a filament drying function, but even as basic feature as drying filaments during printing is not available. To be fair, Bambu Lab said that they were working on it, but again I'm afraid it will have too much limitations. In my opinion, instead of completely locking out all of these experimental possibilities, it would be far better if Bambu Lab simply gave warnings or had a hidden option that let experienced users decide how they want to control their printers. This brings us to the slicer. My main issue with a Bambu Studio on these second-gen printers is that it lacks convenience for advanced users. It doesn't even remember previous configurations when switching printers, has bugs like the part cooling fan sticking at high speeds, and won't let us save us values such as flow dynamics or exhaust fan speed in the filament profiles. It isn't a bad slicer, but the missing features that makes advanced users' life way easier is what makes us looking in the other direction. However, after Bambu Lab's security update, Orca Slicer is no longer an equally convenient option. This is why I wish Bambu Lab would work way more with enthusiasts of 3D printing community to keep all the sides happy. When I heard about these second generation machines, I thought that by trying to make printers combined with lasers and all the cutters, Bambu Lab would sacrifice the most important aspect, the print quality. Not only did they not do that, they even raised the print quality bars so much higher. I really don't like all the limitations that come with controlling the printer, but I can't deny these second generation printers produce the best looking prints I have seen so far. Hopefully this testing video will help you choose. If you have any questions or want to share your experience with these printers, feel free to do so in the comments below. Check the affiliate links to support the channel and leave a like and share the video if it was helpful. Huge thanks to all the people who support my work on YouTube and Patreon. Well, that's all from me, and we'll see you next time.